Okay, hi everyone. We are here doing Orphan Language Design Review, continuing foreign function related functionality. So, Christopher, where did we get to last time?
Right. So let me see. So I think one of the things from last time was we talked about having a foreign function load, like there's library function load, and then there's a foreign function object that returns. So, we that's now implemented.
So remind me, that first argument there is from find library. That thing is a
oh,
tag. What is that?
yes, I forget if we had this last time. I think we might not have. So basically this is now kind of a required argument. This is basically just it's the same as the first argument to library function load. It's the path to the library, or it's the name of the library that it will call find library on. Um,
And is that ultimately a file, or is that something more complicated in some registry somewhere?
so right now it is ultimately a file. There's actually a concept which I think is a little bit orthogonal to this because it would apply to the library functions as well. But the idea would be to support either have some kind of library object or to support lists in all these places that expect libraries, because basically there are well there are lots of cases where you have dynamic libraries that depend on each other, and often where they care about things like the load order, right? You have to load one
Mhm.
before the other. And so right. So normally the way that you like to use foreign function load, and I have a real example that I can show in a minute, is you sort of lazily load all your functions by calling foreign function load like this, and this will check if this is loaded, and if it isn't, it will load it, right? But the problem is, suppose this had a dependency. Now you have to make sure the dependency was loaded first.
Yeah,
And
right.
the usual way you do that is you explicitly call library load, but you can't really do that lazily. So the better thing would be if you could put a list there, and then it would load all of them, presumably from left to right or something like that. And then there would have to be some convention about probably the last element is the one that it actually gets this symbol from, because it does at least on Windows need to know which library is add one actually in. Um,
So
so
what
you'd
are our
have some.
precedents for this? I mean, something like get doesn't have, or needs does not have, needs does needs have a way of dealing with subsidiary dependent files and so on?
Well, dependencies in package files are handled not at
in the
load time,
package
but
file.
yeah, in the package file. Yeah.
Right, you can't do that with libraries. So you
I
can't
see what
put the
you're saying.
dependency to a library in the library.
Well, I guess
I
you
would have
can with
thought
some static linking, but you don't know that they've done that.
I would have thought that we'd be better off on associations, that first argument, or something like that, where we say, library arrow, whatever, dependency arrow, whatever, or maybe a library object. Yeah.
Well, now I mean, I know on macOS, like dynamic libraries can list the other libraries they depend on, but
You
I
can't
don't
you
know.
can't
Well,
load them. You can't load a library and then say, oh, what libraries do you need to load? You can't do that. You
Yeah.
So
see,
like
you can
the
use
dynamic
system
linker doesn't
you can
follow those
use
links.
system tools, things like OTOL, to query them as to find out
Right.
what the difference is. But that's pretty hairy stuff, and you don't get totally,
and
you know,
it's deeply platform dependent, and also there's
yeah.
there's sort of hard, right? There's things like, oh, you just built OpenSSL, right? OpenSSL has libcrypto and libSSL, and you have to load libSSL first. Maybe they didn't set that though in all the different flags. What are you gonna do? So
All right. So your proposal is to
yeah,
have a library object, and it surely should be called library object.
sure. Yeah, I mean
That
either
is,
that or a list, right? I think both of these would work. The list is maybe a little less explicit.
well, I'm thinking though that you should distinguish maybe it's a list, maybe it's the name of the actual library, and then maybe it's arrows or something, something where there's a sub list of dependencies, so that
So
it's
maybe it's
obvious
it's
which one.
like it's like this or something,
Yeah, something like that,
or maybe
maybe.
even the other way around, but that
I,
would be a
I
bit
personally
more
think
bizarre.
that's rule abuse in
Yeah.
my mind to
It is
use an
rule
arrow
abuse.
there.
It
Yeah.
is rule abuse. So maybe it's a sub list. Maybe instead of the rule, it's just a list there.
Right. Well,
Maybe
that's sort of like this version here.
Yeah,
Although you
except that
maybe put,
arguably you could do it the other way around with the base
Yeah.
name first and then the dependencies.
right. The only reason to have the base name last, if you don't have another layer of list, is that it's the one that's going to be loaded last.
No,
right?
I know,
Like,
I know. You have to have another layer of list, but I'm
so you have
suggesting
something
that.
like this.
Right, and then the full form of that could be some kind of association that explicitly calls out this is the library, this is the because there might be library paths that are in common and things. So there could be an association version of that.
I mean, I know that this is kind of just convenient syntax, but how often do we expect people to actually be duplicating this dependency information in every one of their foreign function load calls? Because I would imagine that these dependencies are kind of an implementation detail of the main library.
Yeah, I
They might
totally
change.
agree with that. I totally agree with that.
Right. Well, this is why. So I mean, yes, and
Try
this is one of
test,
the other important points
no.
is that like on different platforms, like for example on Windows, I think there's either 1 or 3 libraries for OpenSSL instead of 2, right? And they're different.
Okay, so that raises another point. If there's a library object, maybe it needs an association, a platform-dependent association.
Well, maybe. So okay, so maybe. Right. So I think the 2 versions would be either you have a platform-dependent association, but that's a little weird because it means your library object, on Mac OS now has a bunch of references to a bunch of Windows file names that just don't exist on your computer, right? Another version would just
tough
be
luck. That's part of the life in the jungle.
Sure. Another version would be that basically wherever you set, because I think a lot of the time you're going to set, here's dollar, the library I'm using equals, and then you do switch, and then you look at your dollar system ID or something, and then you say if I'm on Mac, then I want this library, and if I'm on Windows, then I want this other one, right? I mean, this is the sort of most naive way you do this.
Annoying to have to do that. I mean, it would seem nicer to be able to put that in an association so that somebody.
This is the alternative.
Yeah.
Well, I do think. I mean, like having a symbolic representation for this feels a little academic for this specific problem, because at the end of the day, this is a stateful thing. Like you've loaded a library or you haven't, and you kind of, as the developer, need to be sure that you're doing that at the right moment, and you only need to do it once. You're not going to be kind of unloading and loading libraries, and having a computable object to do that with is of limited value, I think.
Yeah, and it's a global thing. You can't have different ones in different places. It's fixed for your session.
Okay, so what are you guys proposing?
Right. Well, what I would propose is basically something like this, where you're going to set it and it's going to be specific to your platform. Like this is really just a reference to your computer. It's like saying file, right? File of some string.
Fair enough. But it seems like the point being made that foreign function load shouldn't have to have the dependencies. It should just be able to refer to a library object, because you don't want to repeat for every one of the 18 functions that you're defining. You don't want to have to repeat. Well, actually, here's a question.
The two ways to avoid that, I think. One is that the way it works right now, which I think is honestly pretty natural, which is just you set a variable, right? And I'll show you. I have a real example I'm going to show in a moment that shows a lot of the conventions I think we want to promote. And it's very common, just have a $, my library, and then have that in all of your files, and you just always put that here. The other alternative would be that just like you can append to the library path, maybe you can append to some kind of registry of named library things, and I can register that the string OpenSSL, refers
I don't
to
think we've had a huge success. That's what we've done with entity stores. And I'm not sure
I think this
like
is
that
bad also because there's all sorts of collision opportunities. It's symbols are scoped, strings are not.
Yeah. Okay. All right. So provisionally, you're saying it's up to the user to manage that. Basically, the syntax will be it's a list in the first argument of foreign function load, and the typical sort of workflow would be to have a variable, a global variable that's set to what that's supposed to be.
Yeah, although I would argue, I mean, maybe I don't know whether it's the list or the library object. I kind of like the library object, but
I think the library object is nice.
Yeah, okay, fine. And this would presumably be supported by all of the different, library load would support this, library function load would support this,
Yep.
etc. Yeah, okay. All right, I think that sounds right. I think that sounds good. Right, so now let me maybe show the example. So I made a little example, not that's particularly practical, but just because it shows some of the conventions. So it's a connection to Postgres because I was doing something with Postgres. So yeah, I'm running a Postgres server over here on my computer. And if I run Postgres connect, it will connect. There's good because it's
Where is Postgres Connect? That's part of your Postgres
yes,
SQL
I have two
link.
Yeah, I have two functions, Postgres connect and Postgres execute, and then a couple of objects. If I give it the wrong thing, it'll give me a proper error message, which it got from, this is a string that it came from Postgres and so on. And then I can try, running a query and getting back a result object. And then, I can ask for, the data set from the result object. And, there's the result of my query.
This particular functionality relate to our whole giant database calling functionality?
Oh, I mean, there's already existing stuff that basically does this in the database system. So this is not super practical, right?
Yeah, okay.
I mean, it's just an example of connecting to a library.
Okay.
Right.
So now let's see under the hood how this worked.
Right. So it's a Packlet. And here's the basic structure of it. So the first thing is I have this symbol that, this string, you presume, right? Basically, this is the path to the main libpq, which is the Postgres client library. And, presumably you'd set this path more intelligently than I have here. Actually, one other reason that's kind of silly, and hopefully will change soon, why it's good to do this is that as opposed to including, the string, some string that's on your library path in every call, is that actually right now find library is a bit slow because it's there's some caching that it could do, but it doesn't do right now. And so basically when you call foreign function load and you don't give it a full path to a library, find library is taking up like 95% of its runtime.
Yeah, okay.
Right. So here I'm calling find file once, which will always be the most efficient thing to do. Maybe when there's better caching stuff, it'll be comparable to including it in every call. But yeah. Okay. In any case, though, so I have this variable here, and then if we look at like how an actual function is defined, basically I lazily load a bunch of foreign functions. And I think it's kind of important that they be lazily loaded because it means that, these don't get loaded at needs time. Like you run needs, it won't load anything. And that means that both one, needs will be faster because it doesn't have to load things. It doesn't have to call find file or find library and so on. And then second, it's also it's also nice because it means that, for example, if you wanted to call needs and then you, for whatever reason, as a user wanted to modify this library path, then you could do that before it suddenly starts just loading stuff. So, right. But then the basic flow is you lazily load whatever functions you want. And then, here's the top level wrapper function. And you can see, here I'm loading the main connect function and here I'm, calling it. And then it's just a matter of like, well, we get back this raw pointer referring to the connection. And then it's, well, there's another function that you give it this connection and it tells you the status, status ID. So then I can just call that, and then I can check it's correct and so on. And if it doesn't work, we can get the error message, convert it to a string, and then put it into a failure object. And
this is
that's
really
what you
quite
saw
nice. I mean,
over here. Yeah.
Right. So, I mean, I really like the way these declarations work for the foreign function load. It's very clean. I mean, you basically just have to copy that out of the C code, which presumably we could in principle have, we could in principle have some technology that would at least take,
That's actually a note. I think Todd suggested this. Right. So this is, so one question would be, so let me take out an example here. So, right. So here's what the declaration looks like right now. but there's sort of two versions of this that you could imagine that would bring it closer to this, the original C that might be useful. So the first thing would be supporting strings here that look more like C types. So maybe in addition to supporting these compiler types, maybe we could support something like this. Whoops.
I think that would be a good idea.
Right.
Yeah.
And then on top of that, if we want to go even more, you could imagine having a sort of a 2-argument form. And this is a little sketchier, but maybe we could do something that just parses it from a C declaration. So, if you read the documentation for PQ error message, it'll probably look something like this. Oh, wrong way around, but right. So something like that, right? That would be the declaration. So maybe you can just pass in that and it will pull out the name. And this is kind of the
cool.
one step before reading a header file.
Yes.
But it's avoiding, we can be more restrictive here. Like you can't have macros in there and stuff like that.
I think that will be cool. And I don't see any reason not to be able to do that.
Right.
Because we can recognize that it's got parentheses in it,
Well, it's also just the 2-argument form, right? This is a 2-argument form. This is totally distinct from these other things. The only case that could be ambiguous is this, in the sense that, maybe maybe it's ambiguous. Maybe we have a compiler type called void, but actually
not lowercase.
Right.
All the C types are lowercase.
The conventions are such that I think it should never be a problem. But it is technically, there could be a collision.
Maybe foreign function load is fundamentally a C-based thing. That is, all the declarations are C-type declarations. There's no possibility of that becoming some Rust declaration or something which has different capitalization conventions.
Well, it's right. It has to be compatible with the CABI. So that basically means there has to be a way of representing it with C types, pretty much.
Right. Like if I were to write a Rust library, which I've done, that exposes a CABI, I might want to put a Rust type in there, but for all practical purposes, if I'm exposing a CABI, I'm going to have to be generating a C header. And at that point, I might as well just copy out the things from that C header anyway. Like it's not worth adding the complexity of N more languages parsing to this when C is like the lingua franca. It's the common thing.
Fine.
So I don't.
Yeah. So I think we should just do this. I think it's really cool.
Yeah. Okay. That sounds.
There's some subtleties though about pointer variables, right? Like an int star could be an array of integers, or it could be an out int parameter, right? Something that's filled in by the function, and they're marshaled totally differently. So there's some subtlety that we're going to have to provide some hinting to for this type of automatic generation,
because of the memory management around those things.
Well, just because there might be different things. An int star you have to read the documentation for a C function, and int star might be.
You have to know what it is. I mean, you can't introspect on it.
Right, but actually, I would argue that's right. So I mean, we talked a little bit about this before. Also, I mean, this is for example, if this function returns a char star, do we automatically convert that to a string? And if so, who owns the memory? Or do we assume it's a pointer to a char or whatever? I think the right answer, and what this sort of tries to do mostly right now, is that it does nothing. It gives you a raw pointer of char, right? And you're responsible for converting that and managing the memory of it and so on, because otherwise there's just lots of magic that has to kind of pop out. And realistically, it's not much, right? You're going to need to put wrappers around these functions anyway in order to make them sort of nice top-level functions. And so it's not hard to add to that wrapper, buffer to string or something like that, if you want to return a string.
I think I understand. I mean, if we did have functions that didn't have to do complex data structure memory management, if it was just, 3 ints going to 1 int or something, then it's all very straightforward. But as soon as you have something where there's memory being managed on one side or the other, it's going to be more complicated.
Right, and you can have, like, I think Todd, you were showing like in .NET Link, or like in .NET with their pinvoke system, there are ways of like representing here where you sort of annotate this by saying, this is an in-out parameter representing a string, or whatever. Like you can kind of give a whole representation of which things are going in where and what's being modified by the caller and so on. But I think ultimately, I think that system ends up being kind of complicated, and we don't really have many really natural ways of, like, for example, if you have a function that mutates its arguments, we don't really have any natural way of doing that in the language anyway. So
Right.
yeah.
So I mean, okay, fine. So let me see on the left-hand side there. Right. I mean, in a typical case, if we have a large library, and again, I wish we had more examples of all of this, where, well, like refprop, for example, is an example of something with a fairly large library, I believe, with many functions to expose. So it'd be nice to know. Oh, it has C documentation.
Well, I hope so. Oh, high-level API. That's probably the C API. Oh no. This is Fortran.
Well, okay, but there is a. I mean, you can see this. This is just a thing with functions with gazillions. It describes things about floppy disks there.
Right. Well, yeah. I can't really comment on this particular library.
Okay. Well, it'd be nice to see. Yeah, I mean, why we're not low? There we are listed there.
Yeah.
Okay.
Right. Okay. But yeah.
I mean, this is an example of a library where I don't think there are complicated data structures. It's just a library where it's doing crunchy stuff, for itself, and then returning fairly simple things.
Right. Honestly, though, I think something like this Postgres library is more realistic. I mean, like, this is more like the kinds of library connections I've done. Like in OpenSSL, it's similar. Like, you have some functions that create some objects, and you kind of need to pass them around, and there's a function for freeing the objects when you're done with them, and
yeah, you're probably
so
right. You're probably right. I don't know how many libraries there are that are like refprop. They're just pure computation libraries. Anyway, okay, no matter. So, okay, let's continue with the design we were looking at.
Right. Yeah. So, I mean, I'm just, right. Maybe I'll just show one other example thing. So then you can see, I mean, here's, for example, the querying function, which is ultimately similar, define a bunch of foreign functions, then put them into this definition here. Maybe the slightly more interesting part would be like the actual sort of result object, from the resulting a query is really just a wrapper around a pointer, right? And a pointer that's sort of memory managed, that when you stop referencing this result object, it'll free the underlying object. And then, if you want to query from it, like, for example, if I want to ask, how many columns are in the result, it's just going to call a C function on that underlying pointer, just return the result. So it's quite natural. Right. But I think that this is realistically what code using this would.
This code looks
like.
really quite clean for what it is. I mean, I guess I have one question, which is, when you're debugging this, what does debugging look like?
Debugging is honestly really nice, because basically the way I would debug it was, well, first of all, I can just run these in an interactive session, especially if I export this variable. I can just run this in this session here, and then I can try calling any of these underlying functions. And otherwise, everything is just in the top level. So it's, it's just debugging as normal.
Occasionally the kernel crashes, but the front end survives.
Yeah, sure. Right. You can, if you do something dangerous, yes, you can have definitely crashed things.
But that's fine. I mean, we have pretty good apparatus for that, because you still got all your definitions. You just rerun them, you fix it, you rerun them. It's all good.
If you have a debug version of the library, you can also attach a debugger to the kernel and then debug in the library.
What does that look like, UX-wise?
Well, I mean, it looks like, ask Microsoft or Apple. I mean, you're running Xcode or you're running Visual
I see. So
Studio.
you have another window. So you have the notebook window up. You're running.
Yeah, I mean, I do that.
Stop
I do that
secret
sort of
debugger.
thing all the time.
Fair enough. Fair
I
enough.
mean, but that's your, we don't make a C-level debugger.
No, obviously.
We
Right.
shouldn't. Right.
No, I understand that, but I
Yeah.
mean, I'm saying there are two windows on the screen. One is,
Yeah.
yeah, I get it. I get it.
Absolutely. Yeah. But that's
Okay.
that's fine.
All right. Well, so I guess the main design.
I mean, this looks about as
questions-
clean as it could be. There's stuff on the left in terms of what,
Right.
how to
Well,
make
so
this linkage.
in terms of cleanness, this is the main outstanding design question,
Okay.
which is that there are a couple of these sort of helper functions. The only one I'm really calling here is this buffer to string one that are kind of needed to manipulate the inputs and outputs of these things, and which
Okay, so show
need
us the complete
design.
collection of these guys.
Right. So here's all the functions. So the main ones are these ones that talk about buffer, right? So basically these are all functions that do things like taking pointers and turning them into strings, or taking strings and turning them into pointers.
Okay, hold on. There's also callback. We haven't talked about callback, have we?
No, actually we haven't, but it's relatively straightforward. But
Why
yeah,
don't we
actually, I
do
guess
callback first, and then let's talk about buffers.
Okay, well, I don't have an example of
Okay.
callback set up here, although I could get one actually. I think I have.
Well, don't you have documentation for callback?
It's kind of out of date. Actually, no, sorry, I do have a documentation for callback. Yes, give me just a moment. Right, no, actually, was there?
Is this passing a function into the library to be called?
Yes.
Right.
I believe I have an example. If I, oh, this is not a good way to. There's much better ways of getting to this. Actually, sorry, just a moment. Right. So here's an example I had similarly connecting to sqlite using this same kind of mechanism. And okay, it's working. So yeah. So here, I'm just gonna quickly, so some of this code has actually been simplified a bit and can be made a bit cleaner now. But right, so I'm just gonna run through this. Okay, so here's an example of the callback mechanism. So there's a function called sqlite exec, and you can sort of see what it does here. This is the C, declaration of it. So you give it sort of a pointer to the database. That's an opaque raw pointer. You give it a string as a char star of a query, and then you give it a callback function. And basically this callback function gets fed a bunch of random stuff that basically represents the callback. So I think the important stuff is this is the number of columns in the result. And then this is, an array of strings with, where for each column it gives you the name of the column. And this one is an array of strings where for each column it gives you the value of that column. And it'll call this callback for every row in the result.
Okay.
So for example here, if I have, let's see, I'm going to make this database object. So here's a DB, which is just represented with this managed pointer. So basically, right, I called the internal open function. It returns an opaque raw pointer. I then used create managed expression to tell it basically, when you're done with this thing, call sqlite close on it. And that's just the sqlite function for closing a database, given a pointer to it. And so that's what this object is here. We need to maybe talk a little bit about maybe some naming with this, and also whether there are ways in certain cases of having this happen by default. But okay. So now if I want to actually, right, so here I can actually call it, in this case, feeding it a null pointer for its callback, and it works, but it doesn't really do anything very exciting. Alternatively, you can, it has a special case. If you give it a null pointer, it doesn't call it. So I'm not doing something that dangerous by doing that. Otherwise, basically here, what I've done is I'm making this callback object where basically I'm giving it a top level function, which this could be any, I mean, this could be F,
Yeah,
but like I'm just
right.
giving it something that will print. And then I'm giving it a type signature, and this type signature is exactly this one right here.
Yep.
And then if I actually run this thing, you see
It would be very nice if you could just copy that type signature from up above and stick it in there.
Yeah, well, that's kind of what we just talked about.
Yeah,
with
I know.
Copying C
I
type
know.
signatures. Yeah, so you would be able to. But right. But so in any case, though, if I run this, you can see it printed twice, once for each result in the query.
Hold on. I'm still internalizing what this actually did. So you pass simple callback, which is effectively a function pointer, just as the declaration.
There is a
above.
function pointer. This is very nice, Christopher. I haven't seen this. There is a function. There is a function being created that's being sent in.
No, I understand that, but I'm thinking about the declaration up above. The C declaration up above is asking for a pointer to a callback function, and this is now delivering that callback function. Simple callback. What is the value of simple callback? That thing that's wrapped as a callback there is some kind of is basically wrapping a raw function pointer. Is that correct?
Basically, yes. Actually, there's one little piece of complication about it, which is that right. So the one piece of complication is that right. So ultimately, this callback, when you pass it into a function, it gets unwrapped, and all that the function sees is the function pointer.
Yep.
However, there's a bit of extra memory associated with it. So when you actually create a callback, it has to allocate these like little regions in memory that the function pointer points to. And as long as that function pointer is being used, you have to keep that memory allocated, right? Because otherwise it's going to point to nothing. And so there's actually a function that's called, I think I call it delete callback.
I saw that, yeah.
Right. Yeah. And so here, what I made, this one kind of is being leaked, or you could say this is what you'd want to do if you want to make a callback, pass it to some external library, and then you want to throw away your own reference to the callback and just have it live forever, and that external library can always call it. This is how you would do that. If you wanted to make a callback that you knew was not going to live on forever in that external library, then you would use like a managed thing. So right now, the way you do that is you'd say create managed expression of create callback, comma, delete callback, right? And this would make a managed object for it.
But why do we need a special function for deleting a callback, right? I mean, right?
Because he said callback had some extra memory.
Well, I don't mean why does a callback need to be deleted, and why do we need a function with the word callback in its name for deleting callbacks?
Why isn't it just delete object?
Yeah, delete object. We're going to have, we know it's a callback. If there's anything special to be done, we know what to do, but there might not even be anything special to be done. Maybe this is just a call for free.
Right. Okay. So maybe it is delete object. So there's a couple. I think that could work. There's a couple of delete functions here, and they maybe could all be delete object. Okay, it's delete buffer and delete callback.
All right, so we're going to get to buffers in a minute.
Right. Yeah, okay, that's the more common case.
But I just want to comment on the callback name. Okay, so you're saying create callback, but I think the name of the callback thing should be at best, callback function, callback object. I don't think it should just be called callback. It's obscure what that means.
Sure.
What do you think it should be called? Callback object?
I think callback to object is fine. Yeah, I mean, some of these other things, I don't use the object, like managed expression. It's just managed expression.
Or should it be called callback function?
Well, but it's not a function. Like you can't.
I see.
Maybe there could be a sub value for this, but this doesn't do anything.
Is it obvious? Wait a minute. Could that do something?
Well, actually, no, it shouldn't, because like, for example, you can do that, right? Or like, I think that gives you the function pointer, right? Okay, it has accessors. So yeah, this should honestly print a message or something. But yeah.
Okay.
Hang on. What is the callback? What's the delete thing doing? Is it just freeing up the expression?
It's freeing the memory that the function pointer points to. When you make the function pointer, you have to allocate some memory, that represents that contains the actual code that the function pointer points to.
Why can't it do that automatically?
because you don't know if you might allocate that, and then you might create a callback and then pass it to some external library, or pass the function pointer to some external library, and then you might throw away your callback object in the top level, but that function pointer lives on in that external library forever. And so that, in that case,
Well, maybe the external library, if it wants to hang on to it, it should do some sort of acquire type of thing that would prevent that.
Well, this is a different model for memory management, right? So one model is basically you create it and then you free it. The other is, you create it and then you increment its reference count and decrement its reference count. I think so far everything here has been just, we haven't provided any direct access to reference counts. We either just have, you create it and you free it, and worst case, if you want to reference count something, use managed expression, and then it's, the reference count is kind of opaque. Maybe we could add some sort of acquire and release mechanism to managed expressions. That might make some sense. I think that's how you would do that.
Hey, I got a simple suggestion. You've got an address in the opaque raw pointer. I mean, at least in my life in using debuggers, those things are always in hex.
Yeah, that could be in.
That's a pain, though. It's a real pain. That you're right. Yeah, it's base form. Yeah. I think you want to.
Yeah, you want to say base form.
Yeah,
base form.
That's input.
Yeah.
And I never remember which comes first. Yeah, that's.
Well, yeah, actually, that can make some sense.
Maybe we give it in base form with sub 16 there, and that way, if you paste it, you do get the right thing.
Or just use 0x or something in front of it.
Yeah.
Well, we got sub 16. That's our version of 0x. We're pandering to the hexing of the whole thing. Hexing is that's which base,
right?
An important demographic for us.
Indeed. Okay. So let's go back to the callback thing. So then, callback object. Otherwise, this looks fine. And then a delete object on the callback object.
Right. So maybe this is. Let me make a note of that. Well, sorry, Connor, were you going to say something?
Yeah, I just wanted to ask a minor question about do we think the word callback or callback object sounds a bit more general than how it's being used here? Because I could conceive of a world where callback is something that's used for I've cloud deployed something and it makes a callback to my local machine or something.
I can see that too.
Well, what's a better term?
I mean, I could see foreign callback. I don't know, just for consistency. I'm not sure.
What is this callback really? It's a callback. I agree that foreign callback does sound more sensible.
Right. So basically, what it is it's basically
library callback,
a function. Sure, although I think foreign is better than library based on the conventions we have. Basically, what it represents a function pointer that basically was created by the language and whose purpose is to call a Wolfram language, evaluate some Wolfram language expression.
I think foreign callback is the right name for it.
All right, fine.
And then foreign callback object would be its object name. So create foreign callback.
Could we imagine the library callback? And I'm not saying we should do this, but library link could support something like that for passing similar callbacks.
Right.
I mean, it's less important because in library link, it's pretty easy to trigger an evaluation. So you can use other mechanisms through there's a callback link object. So it's not strictly necessary to have something like this. But anyway.
All right. Okay. Let's move on. So are we ready to look at buffers now?
Yes. And buffers are probably the more complicated one. So, okay, here's the basic deal. There's a whole bunch of different objects that you can convert to buffers, a bunch of objects you can convert from buffers. There's a lot of overlap. Like, for example, all of the two buffer functions, they take this object and they just return some raw pointer thing.
What is a buffer?
A buffer, okay, buffer here has just been my term for a pointer. And maybe I should be using the term pointer, but maybe I'll explain why I didn't in a moment. So for example, if I say string to buffer of hello, there's a raw pointer, and now I could do something like if I loaded string, strlen, I could call it on this and it would work. So
basically what it's doing is it's taking one of our types. So in a sense, it's like when we say export byte array or something, export byte array takes whatever thing we have and turns it into a byte array. Here, what you're doing is you're taking something like a string and you're turning it into a piece of memory. Instead of it being ordinary export, will spit out a file in the file system. Another externally managed thing, the file system. So I'm going to make a claim that a possible name for this would be, export something like, just like we have export byte array, would be something like export foreign, export buffer, export raw pointer, export something like that. I mean
So let me explain maybe two of the other problems here. So the first maybe this isn't a problem, but the first thing is that right now, all these a lot of two buffer functions could be merged, right? So it's pretty unambiguous. If I give you a string, what you should do. If I give you a list, if I give you a numeric array, you don't really need me to, we could just have.
You might have to give the native type. You might have to give the native type of the
right. Well, sometimes. So this is right. So here's the example. So list to buffer, right? Right now, you need to tell it, it's a cint or something, or it's a, c char.
Wait a minute, it's a cint star.
Well, this is the argument type.
The element type.
Yeah, element type. Yeah.
Quick question. String to buffer, is that UTF-8 or the RM UTF-8 variant, or what is
so
that?
this is not UTF-8, and it needs a character encoding, or it's using whatever the internal Unicode representation that's kind of crazy. It maybe should use UTF-8.
That's MUTF-8 thing.
It should use UTF-8 by default.
Right.
The crazy internal thing is crazy.
Right, I recently learned that string to byte array is documented to use UTF-8 unless you tell it otherwise, which I think makes me think this should just use UTF-8.
Yeah, it should do.
Yeah, definitely.
But it needs, right, this is one of the cases I was going to bring up. So list to buffer, needs to know the type. String to buffer might need to know the character encoding. So this is the small areas where there isn't overlap. Right, so there are small differences between these, but it might be possible to coerce them into one.
Well, I mean, it's just like with import and export. We have all kinds of elements and special options for different import-export types.
Right, so maybe you could do something like this. So to buffer of, hello, this would work. Then maybe, this would tell you that you need to give it a second argument. Maybe this, you can give it char, and if you give it anything other than char or something equivalent, it'll complain. And this is also useful because like one of the other ones is numeric arrays. Numeric arrays, you can technically determine the size from this second argument here. But honestly, I think it's better if you're forced to do it again, or like if you at least have the option to, because these things are very automatic. Like you see here, it just decided, based on the arguments, what type to do. So I think it's bad to rely on that.
What would it do if you specify a smaller size than what size the numeric array actually has?
I think it'll attempt to cast it using the compiler's mechanism for downcasting a numeric array. And if it fails, it'll fail.
Okay, so it won't silently truncate or, I don't know, clip or saturate or any of the other things it could do.
The compiler does, presumably.
Well, I think the compiler actually checks it by default as like safe. It'll do a safe cast, and it'll complain, I think.
Right. This is the kind of thing that's subtle enough that I think complaining is the right behavior. Like you should be forced to get this right.
Right.
It should not
maybe
coerce
eventually
around
we could support something like the method option for numeric array, where you see it has a whole bunch of things. But for now,
that doesn't seem super important. So really,
yeah, I agree.
Okay, so let's go back to the naming. I mean, I'm claiming export to buffer or something, or something like that.
Right, and then it would be presumably import from buffer would be the other way. Okay, and so then now the other
maybe it's just
is,
export buffer, import buffer. which are analogous
sort of
to
here. To import byte array and export. Yeah, I think that makes some sense. So you'd have goes with import buffer, and presumably, so import buffer is a little more complicated because it is ambiguous. So presumably, I'd give it some raw pointer of blah blah blah, and then what do? I tell it I want back a list. I want back a string. I want how do I specify?
We have
that?
a bunch of functions that have things like this where yes, I mean that's exactly what import elements do, right? That's exactly like an import element.
I'm trying to think if there are any cases where you need to parameterize this as well. I guess you do.
Sure there are.
Like
I'm sure there
this.
are. Where you do with
Wouldn't a length?
Oh, length. Yeah, that's an obvious one. Sorry. Yes, almost right. So a lot of them need to know the length. So string can infer the length if you let it assume it's zero, null terminated. Otherwise, you need to be able to give that. So maybe it's
I would argue
third
that
argument.
the second argument, and the third argument could be an association that has all kinds of stuff in it. Or we could do the same thing.
Or
well, third argument, I guess. If the second argument is always needed, which is the type.
Mm-hmm.
The destination type, right? That the second argument is like the import element. It's the destination type.
Yeah. One thing I might say is that, I think this is probably the right thing. Maybe it should have like an operator form or something though, because I'd say this is super common. Like for example, this buffer to string thing where it's just, I call this function, it returns a char star, just assume it's null terminated and give me a string. And I think it's kind of nice to be able to do these like nice short things like this. But I guess we could do that with a, something like that.
Does that work? What? Oh, I see, because it's a one argument form, right? The one argument form is the type.
It could even technically work like this, right? Because it can tell this isn't a pointer. This is, the first argument of this.
I would claim that pointer. 10. Okay. So,
What are these things? What type are they? If I pass one of these things into a compiled function, what type would it have?
You mean this raw pointer thing?
Well, the output of toBuffer.
Right. So this is a good question. Okay. So this is the reason I'm using the term buffer and not pointer, which is a little inconsistent. Okay. So this is okay. You see, if I call this to buffer, it returns a raw pointer. Right now, there are two objects that I have right now. I have raw pointers and opaque raw pointers. They're the same thing, except raw pointers also contain information about the type that they point to. So an opaque raw pointer is basically a void star.
Right.
So the reason, so there's a little complication here. The compiler has these same exact types. It has opaque raw pointer and raw pointer, and they kind of work in the same way. Right now, those types have no automatic expression conversion because we thought
maybe they should.
And maybe they should convert to this, right?
That would be great. I think that would be kind of interesting. Yeah.
Yeah. So I think that makes some sense. The only place
I think if we're going to use the word raw pointer, that has to happen.
Okay, so now the question is,
otherwise we use a different name.
Right. Okay. Yes, I agree. I agree with that. So the question is though, for the buffer functions, the reason I call them buffer and not pointer or something like that is because right now in the compiler, there are these two functions, to raw pointer and from raw pointer, which do things that are from raw pointer actually has a close analog to some of these buffer functions. From raw pointer is either equivalent to some kind of import from buffer or some kind. Actually, I think it's it's
a load. It's reading. It's loading from the address.
Right. So to raw pointer though really doesn't have an analog here because to raw pointer can do things like stack allocation, which is just meaningless here.
All right. Does it allocate, or does to raw pointer just do the equivalent of ampersand in C?
Well, there's a couple of things. So to raw pointer has several usages. Actually, they might even be documented. Okay. So let's go from the bottom to the top because I think this is the easiest to understand. So the first one is basically you give it's something like this. Like the first one is basically equivalent to array, or R of I equals X, right? That's what the last one is. It's basically for inserting values into arrays where the representatives are pointers. The next one is basically star I or star P equals X. So basically I have a value and I want to store it in this pointer.
That's a very weird thing for a thing called to raw pointer to do. I mean, I would expect to raw pointer to just be like an ampersand operation.
Well, it's putting it into no,
because ampersand
operation doesn't exist. So actually, I remember this is, the equivalents are all written in here. So the issue is that ampersand is kind of, it actually doesn't make any sense for ampersand to exist. Ampersand is kind of a C language feature that is kind of incoherent outside of C.
And you can't apply the ampersand to everything. You can't apply it to like a number or something. It has to be to an identifier. So
So these are the real equivalents. So to raw pointer open closer of a value basically
I think these names are not bad actually. I think they've held up quite nicely, I think.
But the point is though that this thing is doing, if you see this, it's doing a stack allocation and then it's populating it.
Yeah.
That is not what this is doing. This doesn't do stack allocations. And it's important for the semantics of to raw pointer that it's a stack allocation that you don't have to free it and so on.
Yes.
That's kind
buffer is a reasonable name for a thing that is sitting out there as a piece of memory that you would have to do something to.
Okay, fine. Well, maybe one other case, maybe just worth mentioning because I kind of forgot it, but it's listed here. So I also have, what is it?
Sorry, what are some synonyms for buffer? Because buffer has this implication that it's for I/O, which this isn't necessarily. I mean, what else could it be called?
Right.
Well, array is another one, but that's not a good name.
Allocated memory.
I mean, it's what it represents is a chunk of memory.
It could memory block.
It could be a single object. It could be 10 objects. Who knows? It's just a
foreign memory, foreign object, foreign.
Well, hold on. I mean, the usages you were describing seemed like they were very closely tied to the idea of the sequence of things, like the fact that the length argument is in there, or that what you're specifying is an element type. So it's more generic than a pointer, certainly.
Well, actually, so this is the thing that I was trying to get to, is that there's actually two other functions. There's populate buffer and dereference buffer, which are basically so all these other functions I've shown, like the string to buffer numeric array, these are all about buffers that point to arrays, right? But sometimes either A, you want to be able to point to individual elements of arrays, or B, you have an individual object and there's no array involved. It's just a pointer to an int or something like that, a single int. Right. And that's what populate buffer and dereference buffer are for. And those, I'm not sure exactly what the analog would be with this import thing. I have to think about it for a moment.
Well, wait, hold on. What do those do again?
So actually, I wonder if I've documented.
The name buffer is really bad if it's a single object. I mean, that gets really kind of crazy.
I mean, I kind of like the idea of the name memory. It's pretty clear that, well, that we're dealing with is memory. It could be a sequence of things. It could not be a sequence of things. What I find a little odd about what you have here, like the distinction between populate buffer, dereference buffer, and then the other ones that operate on list-like things, is that they're making something that is kind of part of a type into two separate APIs, like list-like things and scalar things. And that seems like it'd be better represented just at the type level.
By the way, why isn't this like called raw memory? Just like you have a raw pointer, you could have a raw memory.
Yeah.
And raw pointers represent raw memory.
Yeah, raw pointers point to raw memory.
That's not bad. That's not bad. So wait, let me up here. Raw memory. So instead what we'd have, okay, let me see here. So we'd have import raw memory and export raw memory.
Yeah.
Actually, I should write that here.
That's pretty descriptive.
Yeah, I like that actually.
So how would you represent, like, what would be the type for list-like things versus scalar-like things? And if you're doing import raw memory of a list-like thing, where do you specify the length?
Right. So let's maybe just go through the cases because there aren't that many, right? So if we look at, or let me sorry, just a moment. Okay, so first let's get all of the to buffer
Should we like import and export? It's more like to raw memory and from raw memory.
Yeah, it might not be import and export. Might not be right.
Yeah.
Okay. Well, let's start with import and export, and then we can play around. Okay. So if we're going to have a single export raw memory function, all right. So list a buffer. Right now, this takes a list and it takes the element type. So now this would turn into, what would it turn into? 1, 2, 3, and then what would it be? List like that.
Thinking. I mean, so that's of a list.
Well, what wouldn't it be? Why not use the compiler, like the colon?
Yeah. Why not use type specifier?
Well, list is not a compiler type, so it makes
Why
me a
does it
little
need to know the list
ambivalent.
thing? I mean, it's right there. It is a list. What else would it be?
Oh, that's well. Okay, so maybe this returns a list of. Well, okay. Now here's a question though. So what about the? I was going to get to this one later. What about the populate buffer? Okay, or so sorry, I have one just called create buffer that I think does this operation. So, right. So this is right. This could presumably be create or allocate raw memory. Oh, I think this is out of date. But basically the idea is right. So suppose I have the number 12 and I want to make a pointer to 12.
Yeah, you can just say allocate raw memory of 12.
Right, but how is that? Well, first there's the case of I want to allocate just a buffer, like a quote unquote empty buffer of 12 integers, or actually a different number. A bunch of integers.
I'm not sure that's the right way around there. I would have thought it was like cint. How do you specify that as a compiler type? You want to
you do create type instance of C array of cint with length 1512.
Okay. So create type instance has a second argument, which is a length.
It has the first argument is the type, and all the other arguments are type specific.
Okay. All right. Okay. So allocate raw memory.
But now, how is allocate? Okay, so this is allocating basically uninitialized memory, and export is for allocating initialized memory. But now the only weird thing is if we want to do the case of if we support this, presumably then this is the way of getting a pointer to the number 12, right?
Yes.
I guess it's a little weird. I guess it's actually okay.
I've got one more case for you.
These are equivalent, right? These are actually mean the same thing.
I got one more case for you. You want to allocate a array of length 1,000, but you're only filling in 2 elements. How do you do that?
I think you allocate it yourself, and then you use something like populate buffer. To point. Yeah. The populate buffer is basically the lower level,
populate raw memory
poking thing.
Populate raw memory.
Oh wait, Connor, you were just suggesting write raw memory?
Right. I think it's more standard terminology than populate.
Right. Yeah.
All right, hold on. Let me write these down though. So we'd have populate buffer goes to write raw memory. And then what would dereference buffer be, which is the analogous thing the other way? Yeah.
Write and read, I mean.
Yeah, I think that makes sense. And it makes it clear this is an unsafe operation. Like, danger. You will crash your kernel if you ask for an element that doesn't exist or something. Okay. What about?
Can you actually read raw memory of a raw hexadecimal address?
Yeah, of course. But it might explode. It might segfault.
Yeah, I understand. But how do you do that? Do you just give the raw?
You read raw memory of raw pointer of.
I see. The number.
And then this would presumably assume that this is just a pointer to a C char, and presumably then this would assume it's an array of C chars, and it's going to give you the 4th element, and maybe you can do something like
I'm sorry, where's it giving the 4th element? Wait a minute. Read raw memory 4. What does that mean? I thought we were giving
That means this is an array of C chars, because a
Yes.
pointer, you don't know if it's a pointer to a single element or an array.
No, I get it. Right.
So this assumes it's an array and we're getting the fourth element.
So
Just
that's an
hold on.
offset.
That fourth is an offset, isn't it?
Well, okay, this is right. This is a good
It's
question.
not a
So
part number. You see, it's
from raw pointer, we made the kind of agonizing decision, which I'm still not sure either way whether it was right, that the second argument is an offset, which starts at 0, as opposed to an index, which starts at 1.
I
Now,
think it should be an offset. Yeah, go ahead.
well, the argument for being an offset is that it would be more like from raw pointer, and it's very C-like. The argument for being an index is like if you want to have something like a span, I'm not comfortable having an offset in a span, right?
yeah, right.
Yes.
And I think having something like a span could be quite useful.
What about negative indices?
We don't know how long it is.
Okay.
Yeah.
One thing I realized that is a sign of age in general, whatever, the pointers that you get back here, I was thinking, these are really long pointers. And I realized I haven't used a raw debugger since 64-bit
They
addresses came in.
But we don't have 128-bit machines yet, so.
Right. Okay.
I think it has to be an offset. I think it's too weird. We're dealing with memory.
I kind of think it has to be offset as well.
Yeah. But, we have other things. We have that are labeled from 0. We have bits. So we have a 0th bit. We don't have a first bit.
In what?
Well, in numbers. So they have a 0th bit.
Do we have a function that gets you the 0th bit?
Well, we talk about, if we get
integer digits. Integer digits has that.
Yeah.
Do we have anything that's like an operator form of a part specification that people could use if they really wanted to?
Extract?
I always wonder if take had take doesn't, but yeah, I think extract might. Yeah, extract does.
Yeah, so you could do extract of an index, or presumably a span works too, or up to, and all the other fun stuff.
Why? Look, that span could just be a list here, because a list, this is a pure one-dimensional object. This is not multi-dimensional memory.
Right. So maybe it takes essentially a take spec. So it takes 3.7 or 3.8, and then we could do maybe this takes every second.
Yeah, I think so. I think it takes a
take spec of offsets.
Right.
And you don't want to get the 3rd, the 8th, and the 2nd thing.
You want to get offset 3, 8, and 2. What?
Well, actually, that's a good question. Right. Does this get you offsets 3 through 8, or does this get you offsets 3 and 8?
3 through 8.
Is this a span or a list?
I think it's a list. I think it's a span. And if you want the other thing, then you put them in sublists.
Fine.
Okay.
Yeah.
Is this supported by? Okay, so I'll just look at what take does. I'll just emulate what take does, because take already has this list mn.
Yes. It's a take spec. So if this is a take spec, on the other hand, the 4 is not a take spec. The 4 would get you the 4th element. So there's a bit of confusion here.
That's true. Yeah. And I think it's useful for that. I guess you could do that, but it feels a bit bad.
Or what's more useful? Or is it in fact the case that you often want to get the whole array?
Actually, take doesn't even support this. I think you have to give it like this. Or
no, that's
no, that's multi-dimensional.
There's no way to do it. There's no way to do it.
Right.
Yeah, so maybe take specs are not the thing then.
Okay, but hold on. Is this okay? Read raw memory. There's a question of how the offset works. What other things do we have to solve here?
You mean in general? Or?
Yeah, in general, for read raw memory, write raw memory. Is that more stuff to solve?
Yes. So there's one big thing to solve, which is anything that generates a pointer. The question is, does it generate a managed one by default? So right now, if you call create buffer any of these functions, right? I don't even remember what this takes, but okay, there we go. It returns a raw pointer, and now this is a memory leak if you don't free it yourself. So it's very common. So for example, if I call string to buffer myself, it's very common that you have to put this around it before you really do anything with it. The question is, maybe these should return a managed one by default. And then there's an option where you can say something like,
Managed goes to
memory
false.
management, goes to false.
What's the thing for borrowing? Don't we have a thing for extracting?
There's two ways to borrow. So the first thing is that if I have a managed expression, if I pass it into a foreign function, it'll automatically unwrap it, which is effectively borrowing. Otherwise, you can always just ask for, or I think it's called expression, actually. You can always ask for the payload. There's actually, I shouldn't get into this, but there's a little bit of subtlety about the expression versus the payload, which are almost always the same, but they can be different. Because basically we have things for basically casting pointers. So for example, if you have a raw pointer and you want to make it opaque, or if you have an opaque raw pointer and you want to annotate it with a type, you can always just say opaque raw pointer of a raw pointer. Or like, for example, if I wanted to say, you think this is a pointer to integer 8s, but it's actually a pointer to integer 64s, right? Which is a common thing. You want to sort of, especially because functions like read raw memory, they look at the type that this is pointing to. That's why you don't have to tell it what type it is. So the point is, if I say raw pointer of this managed object, and I tell it, actually, you're a pointer to an integer 64, you see that now the value has changed. And so now everything will treat this like an integer 64. But critically, the payload is still the original one, because basically there can only ever be one underlying managed object, right? Like it has to know, because you don't want it to call free more than once. Whatever. This is kind of a subtle thing.
Right.
Yeah.
Let's come back to, by the way, in the create managed expression, why is delete object, as it would now be, not the default second argument if you only give one argument?
Maybe it should be. Yeah. Okay. Let me think about that for a moment. So first let me make a note. So create managed expression could default to delete object. So the only minor concern I would have is that you can only use delete object on it if it's something that we made, right? So it might look like an opaque raw pointer, but if it didn't come from, allocate raw memory, if it actually came from Postgres, you better not call delete object on it, because that'll crash.
Don't we know?
No. Like I don't think there's any, if you just have a pointer, I don't think there's any real good way of knowing whether it'll crash when you try and free it.
No, although we presumably, if we actually have this as a symbolic object, it could have tagging inside the symbolic object that says I was created by, if you're literally passing it unchanged from one place to another, it could maintain tagging of whether we created it.
Let me think about that. So the idea is that the single argument form of create managed expression would only work if you applied it to the sort of unchanged result.
Yes.
Of,
yes.
I'm thinking about that. It does seem a little magic.
Well, it can tell you that the magic, that there wasn't enough magic. If it wasn't there, it'll just give you an error message. It'll tell you
right.
Argument.
The alternative, though, to be clear, the alternative would be that all these functions like allocate memory and raw memory and so on, just by default give you a managed one. Well, you have to ask for an unmanaged one, in which case, you wouldn't need that.
Which seems somewhat sensible for them to do it by default.
Right. Most of the time you want a managed one, but you do need the option to make an unmanaged one. And I think it'll be pretty obvious. Now I think about it, if you look at how this displays, it's pretty darn obvious it's giving you something that's memory managed.
Yes.
So, because an alternative design, which I had I considered, but I sort of didn't do, would be that you have all this memory management information inside of the raw pointer. So all you see is raw pointer, and it has some little indication that, by the way, I'm a managed one. but
I think what you
right.
have is right.
Yeah.
Minor comment. I think given if the freeing function is usually delete object, you could elide it in the case where so that you have a more beautiful looking managed expression blob. So that it then just says managed expression of raw pointer.
Yes.
Just to make it look nicer. I mean, it's not super, the main thing you get from that is it's managed, it's a certain type, and there's a meaningless piece of hex.
Let me just allocate. So okay, allocate raw memory and friends, return managed, right, managed expressions. So, right. Well, now, yeah, and then the only times when it's a different freeing function, it's okay. I think that usually the freeing function is delete object for relatively short-lived things. The things that where it has different freeing function is like, for example, if I look at, if I go way up here, right, if we look at this Postgres connection, okay, so I have this con. So let's see what this actually has inside of it. The input form will be a little bit broken right now, but right. So if we look at, so basically the first argument is just, or actually, right. Well, let me just get the managed expression out. Okay, so here it is. So we've got a pointer, and the freeing function is this PQ finish, which is the Postgres function for freeing, closing a connection. Mm-hmm. This is super typical. But
right.
Yeah.
So this is something where there is a complex data structure created by essentially in a foreign function. And yeah, it needs a foreign function to free the foreign created thing.
Mm-hmm.
Makes sense.
All right. So what about, the option to tell it, what is it? Is it memory management?
I would think so. Well, let's see. Okay. Managed expression. Yeah, I think that's a reasonable name.
Okay. Let me. One other relationship to some compiler stuff. There's a function. Yeah, there's an experimental function called unmanaged object. So there's kind of an analogous type in the compiler that's analogous to this managed expression that's just called managed. And basically, it's very similar. So right now you create one by saying create type instance of managed, comma, your value, comma, the freeing function. I think that if we had something like this managed expression mechanism, it might be worth unifying it with this. So maybe in the compiler, you would write this.
Yeah, that sort of thing.
Yeah. The term expression might be a little bit wrong. I mean, it's not literally an expression, but
an instance.
I mean, it could be object.
Yep. Yep.
And then this could be a managed object as well, then instead of managed expression.
I think that's better. I mean, more fully, it would be memory managed object. And perhaps it should be, so people don't get confused.
Let me think about that. So other than it being a little bit verbose.
I was going to mention, I find the managed name, like I know it has a long history, like it's part of library link too, but it's just very unintuitive what managed means. I get it, I mean, it's not even unintuitive, it's just unclear.
What about changing the name managed expression to memory managed as a wrapper?
Mm-hmm. And then what would it be? Create memory managed object?
It'd have to be create memory managed, which is a bit weird.
I mean, is memory managed object really that long? Maybe it is.
No, it's not that long. It's long, but it's not something you'd be typing all the time.
Yeah.
Well, it is. This is a function that you commonly kind of throw in right after a function call. Like you see that here. If I go back to my connect function, right, you see it right there, just thrown in. And that's very typical, right? Like I create this thing, I check that it's correct. Now that I know it's correct, wrap it up so that it will be freed when it's done.
I see.
What if, I mean, if we had a memory object type with an optional managed option?
Well, that would be the, so two points here. So one
yeah.
point is that's a little bit like the raw pointer that knows that it's memory managed. I still think it's a little.
I think it is different though, because a pointer is like, a pointer is a lightweight thing. It's a pointer, right? But if we had a memory object, I feel like it's a little, we have a little bit more license.
What is a memory object as opposed to raw memory? I mean, raw memory is.
I also think though that the managed expression is more general. Like I think the managed expression, honestly, you can use outside of FFI stuff, although I don't think it's terribly useful. Like you could use it for, I'm opening a file stream and I want to make sure that it gets closed when I'm done with it. Like
so then
this thing is
managed object.
I mean, and create managed object.
Because if it isn't, if it applies to things that aren't memory, then it's just managed object.
Yeah. It is more general than memory. It's just that's the most obvious use case.
I mean, can we think of names up along the lines of like cleaned up object? Obviously not that.
We've
like
got
managed
with cleanup. We've got the function with cleanup for something completely different. Well, it's not completely different. It's very similar actually.
Well, this would be a self cleaning object.
Exactly, whatever it is.
Hygienic object.
Hygienic. Is there a term for this term, like this behavior in cats?
Well, there's hygienic macros. So
really?
I don't think this is a very serious.
No.
Yeah.
No, but I do think like manage is it's just too generic of a word. Like it sounds like it's doing all kinds of fancy stuff when all it does is call a function when the object goes out of scope.
Well, another
scoped object maybe
counted.
Yeah,
it's not scoped though.
No, because that might have different technology.
Right.
Okay.
We want to leave that vague.
And scoped, I think, also makes it sound like when it leaves one scope, but it might exist in more scopes. You know what I mean?
No, good. Yeah.
Collectible object.
What about
that? Sounds like
like
a baseball card or something.
Just type in auto cleaned.
Will be auto
clean.
I'm not sure cleaned is the right word.
Auto deleted.
Auto cleanup.
Auto freed.
Well, but again, it's not necessarily deleted. It's just when the thing's reference count goes to 0, it will call this function on the payload.
Well, we say on free in compiler callback.
What is the semantics of with cleanup?
It's to do with exceptions.
I know that, but
guarantee.
No, it's with cleanup just says that this thing. Okay, first middle cleanup, right?
Yeah.
Yeah.
Or just middle cleanup. Yeah.
Okay.
So I've never totally been sure the first one's completely necessary, but
yeah, I think it's there. I think it's because the first is like
thing.
exception. It's exception immune in some terrifying way.
But if it throws an exception, you could just put a semicolon instead of that first comma, and it would.
No, I don't think so because of the exception handling.
I think the problem is that if you do, well, yeah.
That first is like a critical section type thing.
Yeah.
Different topic. Okay, but the basic point is that what this is doing is just like with cleanup. This is a wrapper for something which is an auto cleanup type thing.
Actually, it is like abort protect around first with a semicolon. I think that is exactly what it is.
Yeah, that's probably right.
Yeah.
Okay, I mean, the most common use case here is memory management, but as you're saying, there's an auto cleanup. Just type in auto cleanup. It's a bit weird.
Yeah.
I know that the front end. Well, what is this? I mean, in like what do people call this? Resource in C++. Resource acquisition is initialization. Is that the acronym? RAII,
it's the other way
I
around.
guess.
Initialization is acquisition is the other way around, right? It's the other way around, isn't it?
It's RAII. Resource acquisition is initialization, but in the implicit, when it's dropped, that something
I need to disappear
runs.
soon.
What about like something like destructed or just with destructor?
It sounds explosive.
Sounds dangerous.
Yeah.
But remember,
to be honest, it is to do with memory management, because it is when the expression reference count.
Yeah. Is it reference counted?
The expression is reference counted.
Yeah, but
you
don't actually. I don't think we want to commit to that. That's an implementation feature. It's when the
maybe
thing
it's garbage
being
collected.
used. Yeah,
right. Or the compiler where it can be confident about when to deallocate something. Yeah.
Yeah, maybe it would. Yeah, exactly.
Well, I have to say, managed object to me. I mean, Connor doesn't like managed, but
I just think this is like a concept that's. Yeah, but it's a concept that so many people are familiar with from like so many other languages. Managed seems like an unnecessarily unfamiliar term.
Is it?
Well, managed is used by Microsoft, right, for years and years and years to distinguish between like the C unmanaged world of C, C++, and the managed world of .NET, right? So people who are familiar with the Microsoft technology stack, the word managed is very understandable.
Yeah, I think also memory management is like the general term for garbage collection or ARC or whatever.
I think so.
Right. So I think
if we're calling it managed object, though, the one kind of question is this function, which I guess we could support, although I think it would be marginally useful in the top level. Essentially, what this does, it does something honestly a little bit weird, and I sort of maybe question it a little bit. Basically, what it does is you give it a managed object, and it gives you back the value inside that object, and then it invalidates the managed object. So that object will no longer be automatically freed.
But that might be useful, Christopher. Like you pass it, you might want to do that. And it would save you from having to keep a reference around to the expression. Might be right. I mean, that might be handy.
Actually, okay, I guess that's true. You probably do need a way of doing this. Like otherwise, there'd be if you have a managed object and you want to say, actually, I don't want you to free this when the reference count goes to 0, there's nothing you can do right now.
Yeah, you already set that fuse.
Okay, fine. So actually, this makes a lot of sense. If there's an unmanaged object that's because here's the thing: the original purpose of this function was this was the way you get the value out, but really maybe the purpose of this function is this is the way you put out the fuse, and it happens to give you the object out as well. But maybe we can have another function like borrow managed object or something that just gives you the value.
Yeah.
Why isn't it a sub value of managed object?
Right now, for the managed object, it is a sub value. In the compiler, it could be in the compiler it could be a sub value too.
It could be,
yeah. Right now, it's if you just say value.
All right. Have we basically come to the end of what we need to do right now, or are we?
I think we have. Let me just quickly look at.
Let's talk some more next week, Christopher. I'd like to discuss like in and out of the compiler with this actually. So
I think actually we hit everything. So
null pointer queue is something I haven't seen before in your list.
Yeah, that one I added recently. That was kind of on a whim, but I think it is actually a useful object.
I think it's useful. I have to believe that's useful. Because otherwise you're weirdly going in and digging inside and looking for zeros and things, which is crazy.
Yeah.
Right.
No, you don't want to do.
Yes. Okay. There is a little bit of relationship to some compiler stuff. Like if you want to have, like I had a use case where I had some foreign functions, but then I wanted to compile a little program that used the foreign functions. But I think there's actually an obvious design for that. Which is,
I'd like to talk about that, Christopher. Maybe we could talk about that in more detail.
Yeah, sure. But I think this should work, right? Where it just pulls out the function pointer from this, or it pulls out the library name and everything that it needs from that.
I'd like to.
Is it a true statement that with all this foreign function stuff, back in the day, I used to write C programs, use template files, call them through MathLink? Is it the case that with all of this, that technology, that's irrelevant? I can just make a C.
Correct. Yes.
Yeah, I think so. And it'll be way more efficient.
be more efficient and more flexible and easier.
Good.
That is good.
We should figure out how to indicate that those things are, how to give people pointers to the new stuff.
Right. But there's one important difference, though, is that those template functions that you write run as an external process. If this stuff crashes, your kernel goes down.
I see what you're saying.
Yes. It's a little more dangerous.
We could have, fine, whatever. We could have some blob that runs, in an external process.
Why not? Why not have the library? Why not have an opportunity to have a harness for the library that can run as an external process?
Yeah.
Is there a good reason?
We could have we could have a maybe there'd be some version of foreign function load, maybe a different function or maybe an option that basically says load it in some sacrificial executable that will communicate a math link. Yeah, that's kind of a little more complicated. Like I think that requires.
We could fork the process, Pod. Fork it.
Yeah, there we go.
What are you, forking expert?
Forking.
No, but go ahead. Okay.
I was just gonna say I put 2 ideas in chat. I don't know if we want to really get into them, but
a symbol called null pointer.
Yeah, that would double equals compare with raw pointer, not triple equals, obviously, and could be used instead of raw pointer of 0, just as a shorthand and
I think
say arguments and things.
Well, so 2 concerns. One is just I think that equal is a little bit, equal does all sorts of weird stuff.
I like the predicate because it can be polymorphic and such like. So
and it's a Q function, so it's going to return true or false. It's not going to. If you put it in an if statement, you don't have to be afraid that it's going to return a value.
Null pointer Q, it seems better than equals null pointer.
The other thing is I think people will confuse null pointer and null. They'll try and do blah 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 equals null,
God.
and that won't work.
Oh, yeah.
Yes.
Yes.
All right.
Which they'll do anyway, but yeah.
And as a shorthand for a function argument, it probably doesn't add much value over just raw pointer of 0, perhaps.
Yeah. We could have you could have null
zero.
pointer evaluate to opaque raw pointer of 0, but I think opaque raw pointer of 0 is pretty easy and maybe gets you in. Well, I guess we could have that. Like we could have that just be defined. Right.
Yeah, I don't know if that might be too marginal to be worth it.
I think we need to think about this carefully.
You do see it here. Like it is quite often. Opaque raw pointer of 0 is I use it all the time.
Yeah.
Okay.
Yeah.
Good stuff.
This sounds good. I think we've solved basically everything. The only things might be a little bit of ambiguity around some of these second arguments to import and export, but I need to just do some experiments to see how ambiguous it really is.
Let's talk about this next week, Christopher. I'd like to talk about the compiler aspects of this.
All right. I need to run.
Sounds good.
Okay. Cheers, everyone.
Okay.
Bye.
Bye. Good stuff.